metal and a nonmetal ion. Sometimes these ions can be combined with polyatomic ions. So we could have a metal and a nonmetal ion, a metal and a polyatomic ion, a nonmetal ion and a polyatomic ion, or just polyatomic ions combined. Positive ions, which are usually metals, are called cations. Some examples include K+, Na+, Ca2+, Mg2+, and Al3+. Negative ions, which are usually nonmetals, are called anions. Some examples include Cl-, F-, O2-, S2-, and I-. Polyatomic ions are ions composed of multiple elements, which can be positively or negatively charged. Some examples include NO3-, SO4 2-, NH4+, CO3 2-, and MnO4-. So if we have an element, how do we predict the charge an ion of that element will have? Group 1 elements, which include Li, Na, K, Rb, and Cs, all form 1+ ions. Group 2 elements, which include Be, Mg, Ca, Sr, and Ba, all form 2+ ions. Aluminum, or Al, always forms 3+ ions. Transition metals vary and will be indicated. Transition metals are the middle block of elements in the periodic table. Group 17 elements, which include F, Cl, Br, and I, all form 1- ions. O and S, oxygen and sulfur, always form 2- ions. Polyatomic ions must be memorized. There's a list of about 20 common polyatomic ions, which you should be very familiar with. Naming ionic compounds. So when we want to name these ionic compounds, what we're going to do is name the positive ion before the negative ion, and if the negative ion is not a polyatomic ion, add IDE to the end of the name. For example, NaCl. So we wanted to name NaCl. NaCl is composed from Na+ and Cl-. Na is sodium and Cl is chlorine. Na+ is the positive ion, we put that in front first. The negative ion is not a polyatomic ion, so we're going to add IDE to the end of the name. So we go from chlorine to chloride. Altogether, NaCl is called sodium chloride. Let's try another one. KNO3. KNO3 is composed from K+ and NO3-. K is potassium and NO3- is nitrate. We put the positive ion first, and the negative ion in this case is a polyatomic ion, so we don't need to do anything to its name. Altogether, this is called potassium nitrate. Let's try some more examples. Ki. Ki is formed from potassium and iodine, so it's called potassium iodide. We put IDE at the end of the negative ion because it's not a polyatomic ion. Let's try another one. MgF2. MgF2 is from magnesium fluoride. We add IDE to the end of the name because F is not a polyatomic ion. NiSO4. Nickel sulfate. SO4 2- is a polyatomic ion, so we don't need to change the name of SO4. Next we have TiBr4. Now since Ti, or titanium, is a transition metal, it can form multiple ions. It can form Ti2+, Ti3 plus, and Ti4 plus. Well, which one is it in this case? Well, since we're forming this with Br minus, and we have 4 of them, it has to form with Ti4 plus. 4 plus 4 minus will equal out to 0, which is the overall charge on TiBr4. So now that we've identified that we are forming Ti4 plus with Br minus, how do we name this? How do we differentiate between Ti2 plus, Ti3 plus, and Ti4 plus? Well, what we do is this. Ti2 plus we call titanium 2. Ti3 plus we call titanium 3, and Ti4 plus we call titanium 4. We just use Roman numerals to differentiate the charge on the ion. So now we've identified which titanium name we're going to use. We're going to put the positive ion first, titanium 4, and then bromide. We add IDE to the end of the name because Br minus is not a polyatomic ion. NH4HSO4, which is made from NH4 plus and HSO4 minus. These are two polyatomic ions. NH4 plus is ammonium, and HSO4 is hydrogen sulfate. So this compound is called ammonium hydrogen sulfate. Al2O3, which is formed from aluminum and oxygen, aluminum oxide. We add IDE to the end of the name because oxygen is not a polyatomic ion. Next we have BaCl2 dot 2H2O. What is that dot 2H2O? When we see this dot 2H2O, this is called a hydrate. What this means is that this compound contains 2 molecules of water. So how do we name compounds that contain water? Or how do we name hydrate compounds? What we're going to do is name the compound normally and add prefix hydrate as a separate word at the end. So what does that prefix hydrate mean? If we have one hydrate, the prefix is mono. If we have 2 hydrates, the prefix is di. If we have 3 hydrates, the prefix is tri. If we have 4 hydrates, the prefix is tetra. If we have 5 hydrates, the prefix is penta. And if we have 6 hydrates, the prefix is hexa. So in this case, we're going to call this barium for Ba, chloride for the Cl, and then dihydrate for the 2H2O. We use the prefix di and hydrate for the 2 hydrates. Li2C2O4. Li2C2O4 is made from lithium and oxalate. So this is called lithium oxalate. Next we have Na2SO4.5H2O. So since we see that .5H2O again, we recognize that as a hydrate. And when we see hydrates, we remember we're going to add that prefix hydrate to the end. So let's pull up those lists of prefixes again. So we remember that we're going to name this compound normally, then add the prefix hydrate at the end. Na, sodium, SO4, sulfate, and then finally pentahydrate from the 5H2O. We use prefix pentahydrate for 5H2O. Next we're going to talk about writing ionic compound formulas. So if we were given the name of an ionic compound, we're going to first identify the ions present. Step 2, we're going to, quote, cross the charges. We'll see what that means in a little bit. And step 3, divide the subscripts by the lowest common denominator. So let's look at an example. If you were given calcium oxide, we're going to identify the ions present. And calcium oxide, we have Ca2 plus and O2 minus. We've completed step 1. Next, we're going to cross the charges. What that means is we're going to take Ca2 plus, that 2 plus charge, and we're going to cross it down below the O. And we're going to take the charge in the O and cross it down below the Ca. So we end up with Ca2O2. We cross the Ca2 plus charge next to the O, and we cross the O2 minus charge next down to the Ca. Next, divide the subscripts by the lowest common denominator. The subscripts we have are 2 and 2, which means the lowest common denominator is 2. So we're going to divide each subscript, which is 2 and 2, by 2. So we get Ca1O1. And since having that 1 over there is kind of redundant, we just call this CaO. And we're done. Let's look at another example. Potassium chloride. Potassium chloride is made from K plus and Cl minus. We've identified the ions that are present. Next, we're going to cross the K plus charge down next to the Cl minus, and we're going to cross the minus 1 charge down next to this K. We end up with K1 Cl1. The lowest common denominator here is 1, because all we have is a subscript 1 and another subscript 1. So this ends up as being KCl. Calcium carbonate. Calcium Ca2 plus, carbonate CO3 2 minus. Ca2 CO3 2. We cross the Ca2 down next to the CO3, and we cross the CO3 2 minus down next to the Ca. We end up with the lowest common denominator of 2. Dividing each subscript by 2, we get CaCO3. Next, chromium 3 oxide. Chromium 3 is chromium 3 plus, and oxide is O2 minus. We cross the charges to get Cr2O3. The lowest common denominator of 2 and 3 is 1, so we divide 2 by 1 and 3 by 1 to get the same answer, Cr2O3. Potassium perchlorate. K plus and ClO4 minus. Cross the charges, we get KClO4. Sodium chlorate. Na plus, ClO3 minus. Cross the charges, and we get NaClO3 minus. We don't need to divide any subscripts because the lowest common denominator is 1. Iron 2 sulfate hexahydrate. Iron 2 is Fe2 plus, sulfate is SO4 2 minus, hexahydrate is .6H2O. We know it's .6H2O from our list of prefixes. 6 H2Os is hexahydrate. With hydrates, we're going to proceed normally, and that add our number of H2Os at the end. So we cross the charges for Fe2 plus and SO4 2 minus, and we get FeSO4, and we add our .6H2O at the end. Sodium oxide, Na plus and O2 minus, forms Na2O. Copper 1 hydroxide. Copper 1 is Cu plus, hydroxide is OH minus. Cross the charges to get CuOH. Aluminum sulfate. Al3 plus and SO4 2 minus. Cross the charges to get Al2 SO4 3. When we have multiple of the same polyatomic ion, we put parentheses around that whole polyatomic ion to indicate that we have multiple polyatomic ions. In this case, we have 3 SO4, so we put a parenthesis around the SO4 and add a 3 at the end. Barium iodide, Ba2+ and I-. Cross the charges, we get BaI2.